Wanted to give you a little bit of further instruction about a convenient way to run the Knex lab, the query builder lab. It's a little goofy to try to orchestrate a collection of multiple asynchronous operations in a coherent way. So this is one way to kind of slice and dice that. There's 3 queries in the assignment, so I'm just going to give you the code for the first one for free. What I've done is, rather than trying to just string this all together as one query after another, and because they're asynchronous, that kind of forces us to sort of orchestrate their behavior. So the first one gets done before the second one starts, and that just gets kind of messy if we do it all in inline code. So I've created 3 functions, one for each query, and the first one here is just called query1, and it takes a parameter here that I've just called Knex, and that's actually the Knex object. Sometimes students are tempted to create a bunch of these Knex objects, and that's really not necessary. We can reuse the Knex object as many times as we want to inside the same execution. So I'll show you where I create it down below, but basically we're passing this Knex object in. I've called the console log function to just print a little header for this piece of output. I've put a new line at the beginning here to leave a little white space there. And then I've gone ahead and created the query. Now, what we saw in some of the examples in the talks are the use of the Knex object, and then you call the select method on it to specify the columns that you want to come out, and then the from method to choose the table that you want to query, and so forth. What we saw in most of the examples in class were using that Knex.select.from and so forth, and then we would right away have a .then method whose job it would be to kind of kick off the query. In this case, I want to actually kind of postpone that a bit, because I also want to be able to print the contents of the SQL that's generated by the query as well. So the next statement here is a console.log statement, and what I'm doing is I'm using that query and I'm calling the toString method on it. And remember, this is the thing that converts the query into a string representation of the SQL. So what this is going to do for us basically is print out the query itself, so you can kind of inspect it and see if what you think you're setting up in the JavaScript is actually what you're getting. And then finally, I'm going to execute the query. So we know that when we invoke the then method on the query, that causes the query to actually be executed by the database, and the return value is going to come back. So the then method is going to expect an array of objects, each object consisting of one row in the result set, and I'm passing that in as the argument to this fat arrow function that's inside the then. And this is going to just do kind of like what we did in some of the examples. It's going to iterate over this rows array, and for each row it's going to call this second fat arrow function. It takes as an argument the row that we're working on at this point, and I'm just calling console.log and grabbing the category ID and the name, which of course are the 2 columns that I extracted from the table up above. Notice one thing about the parameters here. We've said that a fat arrow function, if it has only one argument or one parameter, you don't need the parentheses. That's totally fine as well, and I actually kind of prefer that syntax, but I'm here inside of Visual Studio Code and using the prettier code formatter. You can see down here that I've got prettier activated, and prettier will always enclose those things in parentheses, so I'm just kind of going with it. Okay, and then so this is the answer to the first problem. You'll need to fill in the blanks here for the second 2 queries. Now let's look at the kind of the driver here, the code that's actually making this all work. So I've got a function that I've defined here called run queries, and again, just to partition the code in a little bit more sensible way, rather than trying to jam a bunch of individual statements together in one top level collection of function calls. I'm separating these into individual functions. So run queries, it's going to do 2 things. It's going to connect to Knex, and then it's going to run the queries. So this first portion here inside of run queries is just requiring the Knex object and then supplying that Knex object with the connection information. So telling it to use the Postgres driver and to configure the connection to talk to the Faraday database server. So at this point, line 31 here, this Knex object has been set up to do exactly what we need to run all the queries. And you can see here where I finally call query 1, which is what we just got done looking at up here, I just pass that Knex object directly into the query as an argument, and then it goes ahead and uses it to build the query, to print it as a string, to run the query, to consume the results, and so forth, just like we've been talking about previously. Now, in order to kind of get these queries to execute in order, in other words, to let one complete before the next one starts so we don't end up with all the output from these queries all jumbled together, I've decided to use async and await here. So inside the function, when I'm calling this query function, I'm calling it with the await keyword to say, this thing's going to return a promise, wait for that promise to resolve, and when it's done resolving, then go on to the next statement. And because I don't have any code here for query 2 or query 3, I've commented these lines out. You'll have to uncomment them. Notice that because I'm using async await, I don't have to use the dot then and the dot catch. In particular, I can use ordinary try catch syntax inside this function to check for errors. So we can see here that the 3 queries are going to be executed one after another inside the try block. And if anything happens inside of any of those queries that indicates that the query was broken, the catch block is going to catch that error. And all I'm doing here is just printing the error to the standard output. Some of you may not be familiar with console.error. This just basically prints its output sort of just like console.log, except it makes it a little more evident that it's an error message. You might get some other output depending on the error itself. But that's a pretty standard way of reporting an error. And then I have this finally, and we'll come back and talk about that in a second. Notice that because I've got some await calls in this function, I've got to declare the function to be async, right? Because that's how JavaScript knows that this function is going to do this await behavior. And then, of course, I've got to invoke this thing to kick the whole shebang off. So I'm calling the run queries function as the only top-level function call in this whole file. Everything else is encapsulated within a function. Now, let me say something about these query functions themselves. We're using await here, and we know that await works on an expression that returns a promise. And it waits for that promise to resolve, and if it resolves successfully by going to the fulfilled state, it'll just advance to the next statement in the program. And if it resolves unsuccessfully, if it's rejected, the await will cause the error information passed to the reject function under the hood as an error object. It'll throw that as an error so that the catch clause has a chance to catch it. Now, again, that presumes that query 1 returns a promise. In fact, all of these need to return a promise for that await thing to work. If we go back up here, you'll notice one thing that I sort of glossed over before. I'm actually returning the result of this dot then. You remember earlier I said that whenever you use dot then and in sequence, you call the first dot then, and that runs some code, and it takes the result of that execution of that fat arrow function that you give it and wraps it in a new promise and returns that. So that if you have another dot then or a dot catch down the line, there's a promise that is being waited for that promise to resolve. And that's the case here. I've got a query with the dot then, so this is going to actually construct a new promise containing the return value from this function. And that's what I actually want to return back to the top level function that runs the queries. If I didn't return this query, then the await would not behave as we expect. Await always needs to have a promise that's being given as its argument. So the query itself here is returning a promise from the dot then, and we need to send that back to the caller so that the await knows how to wait properly. And the same thing should be true for these other two invocations of the query functions. Again, notice that I'm just creating one Knex connection object and passing it to each of these queries. We could do that all day long with the same connection. Behind the scenes, Knex manages a pool of open connections that it can kind of parcel out to different asynchronous threads as we are executing in this particular instance of the Node JavaScript engine. One of the kind of quirky things about doing this with Node is that when Node thinks there's something that's still active, one of these asynchronous operations or the top level function that you're calling when you invoke your program, if anything is still active inside the Node process, Node won't exit. So what you would see on the command line is that you would run your program and then you'd see whatever output showed up, and then it would look like your shell was stuck because Node is no longer doing anything particularly useful maybe, but it's got something that's still running behind the scenes, and you need to actually go in and intentionally kill off that program, like with Control-C. That's kind of inelegant, kind of clunky. So what in the world is running here when we finish doing our queries? Well, again, because the connection that we've opened up using the Knex library has this connection pool mechanism, that's still sort of active and running in the Node process. And the result of that is that Node won't exit when we get past these three queries. What we need to do is call this function on the Knex object called destroy, and that basically says throw away the connection pool, which releases kind of the last active piece of functionality inside the Node process, and that causes Node to exit. And that will then cause Node to fall through the bottom of this run queries function, and the program will terminate. So that's just kind of something that's really specific to Node. You don't normally have to worry, specific to Node and Knex, right? Because Knex has still got something going on. You need to tell Knex, okay, we're done. And then Node realizes that there's nothing left to do, and it exits out. You might not be familiar with this syntax either. This is an ordinary try-catch block in JavaScript. So it's going to execute the code inside the try block. If anybody throws an exception, like our friend the await here, if the underlying promise doesn't resolve successfully, it will arrange to skip the remaining code in the try block and call the code in the catch block, passing in the object that was raised when the error was thrown. There's another clause that you can add here to the try catch called finally. And what finally does is it encapsulates code that's going to be executed whether we run successfully through the entire try block, or if we end up calling the catch block and doing whatever error handling takes place in here. JavaScript will guarantee that whether it worked fine and we only ran code in try, or whether we actually encountered an error in here and invoked this code, JavaScript will arrange before this whole construct exits to run the code inside the finally block. So it's very common to use finally to just kind of, well, it's usually called finalizing the execution. In this case, what we want to do is tell Knex that it's done doing its thing so that Node can exit normally without having to Control-C our way out of the program.